According to the National Electrical Code and related industry standards, the use of torque screwdrivers is required for specific electrical equipment terminations. NEC 110.14 Fine Print Note Number 14 states that the use of torque screwdrivers is recommended to ensure that maximum tightening torques are not exceeded. Furthermore, IEE Standard 519, titled Recommended Practices and Requirements for Harmonic Control in Electrical Power Systems, suggests that for bolted connections, consideration should be given to using a torque wrench rather than relying on the feel of the installer. IEC 60000 364-5-52 Electrical Installations of Buildings Part 5-52 Selection and Erection of Electrical Equipment Wiring Systems mandates that terminals and connections shall be tightened in accordance with the manufacturer's instructions. Where these instructions require a specific tightening torque, a calibrated torque screwdriver or wrench shall be used. UL Standard 67, which pertains to panel boards, specifies that all terminal screws shall be tightened by a torque screwdriver or other suitable torque limiting device. ANSI/NEMA PB 1.1 on Panelboards echoes this requirement, stating that all terminal screws shall be tightened by a torque screwdriver or other suitable torque limiting device. Beyond these specific references, several other considerations come into play. Firstly, torque specifications for specific electrical equipment terminations can be found in the manufacturer's installation instructions. These instructions are paramount and should always be consulted. Secondly, industry best practices and standards highly recommend the use of torque screwdrivers for terminations in critical applications. These are scenarios where proper tightening torque is absolutely crucial for both safety and long-term reliability. Thirdly, the importance of correct torque cannot be overstated. Over-tightening can damage the conductor or the terminal, leading to thread stripping or deformation of the connection. This can increase resistance, generate heat, and ultimately cause a failure. Under-tightening, on the other hand, can result in a loose connection, which also increases resistance, causes heat, and can lead to arcing and potential fire hazards. Fourthly, torque screwdrivers and wrenches are designed to deliver a specific amount of torque to a fastener. They come in various types, including preset torque screwdrivers, adjustable torque screwdrivers, and torque wrenches with dial indicators or digital readouts. These tools ensure that the correct amount of force is applied, preventing both over-tightening and under-tightening. Fifthly, proper calibration of torque screwdrivers and wrenches is essential. These tools should be calibrated periodically to ensure accuracy. Calibration services are readily available, and maintaining accurate tools is a crucial aspect of electrical safety and reliability. Sixthly, the choice of torque screwdriver or wrench depends on the size and type of fastener, as well as the required torque value. Manufacturers typically provide torque specifications in inch-pounds or Newton-meters. It is important to select a tool that is appropriate for the specific application. Seventhly, proper training is necessary for personnel who perform electrical terminations. Installers should be trained on the correct use of torque screwdrivers and wrenches, as well as the importance of following manufacturers' instructions and industry best practices. Eighthly, documentation of torque values is a good practice. Keeping a record of the torque values applied to each termination can be helpful for future maintenance and troubleshooting. This documentation can be as simple as noting the torque value on a label or including it in a maintenance log. Ninthly, using the right tools for the job is paramount. Attempting to tighten connections without a torque screwdriver or wrench, or using an incorrectly sized or calibrated tool can compromise the integrity of the connection and create safety hazards. Tenthly, visual inspection of terminations is important even after using a torque screwdriver. Check for any signs of damage such as stripped threads, deformed connectors, or exposed conductors. A properly tightened connection should be secure and free of any visible defects. 11thly, consider the environmental conditions. Temperature variations can affect the torque of a connection. In some cases, it may be necessary to re-torque connections after they have been exposed to extreme temperatures. 12thly, be aware of the different types of terminals. Different types of terminals, such as screw terminals, compression terminals, and spring terminals, may have different torque requirements. Always refer to the manufacturer's instructions for the specific type of terminal being used. 13thly, when working with aluminum conductors, use an antioxidant compound. Aluminum is more prone to oxidation than copper, and oxidation can increase resistance and lead to connection failures. Applying an antioxidant compound to the conductor before termination can help prevent oxidation. 14thly, when making connections, ensure that the conductor is properly sized for the terminal. Using an undersized conductor can result in a loose connection, while using an oversized conductor can damage the terminal. 15thly, before tightening a connection, ensure that the conductor is fully inserted into the terminal. A partially inserted conductor can create a high resistance connection. 16thly, when tightening a screw terminal, apply steady, even pressure. Avoid jerking or twisting the screwdriver, as this can damage the screw or the terminal. 17thly, when using a torque wrench, hold the wrench at a right angle to the fastener. Applying force at an angle can result in an inaccurate torque reading. 18thly, after tightening a connection, double check that it is secure. Give the conductor a gentle tug to ensure that it is firmly seated in the terminal. 19thly, when working on energized equipment, always follow lockout/tagout procedures. This will help prevent accidental contact with live conductors and ensure the safety of personnel. 20thly, wear appropriate personal protective equipment, including safety glasses and gloves. This will help protect you from electrical hazards. 21stly, follow all applicable safety regulations and codes. This will help ensure that the electrical installation is safe and compliant. 22ndly, when in doubt, consult with a qualified electrician. A qualified electrician can provide expert guidance and assistance with electrical terminations. 23rdly, regular inspections of electrical connections are crucial for maintaining safety and reliability. These inspections can help identify loose or damaged connections before they cause problems. 24thly, thermal imaging can be used to detect hot spots in electrical connections. Hot spots are an indication of increased resistance and can be a sign of a loose or failing connection. 25thly, power quality monitoring can be used to identify harmonic distortion in electrical systems. Harmonic distortion can be caused by improperly tightened connections and can lead to equipment damage. 26thly, preventative maintenance is essential for electrical systems. Regularly tightening connections, cleaning equipment, and inspecting components can help prevent failures and extend the life of the system. 27thly, proper grounding is crucial for electrical safety. Ensure that all equipment is properly grounded to prevent electrical shock hazards. 28thly, surge protection devices can help protect electrical equipment from voltage surges. Voltage surges can damage sensitive electronic components and cause equipment failures. 29thly, uninterruptible power supplies can provide backup power in the event of a power outage. This can help prevent data loss and equipment damage. 30thly, energy-efficient lighting can help reduce energy consumption and save money. Upgrading to energy-efficient lighting can also improve the quality of light and reduce maintenance costs. 31stly, variable frequency drives can be used to control the speed of electric motors. This can help reduce energy consumption and improve the performance of the motor. 32ndly, power factor correction can help improve the efficiency of electrical systems. Power factor correction can reduce energy losses and improve the voltage regulation of the system. 33rdly, distributed generation can provide on-site power generation. This can help reduce reliance on the grid and improve the reliability of the power supply. 34thly, smart grids can help improve the efficiency and reliability of the electrical grid. Smart grids use advanced technologies to monitor and control the flow of electricity. 35thly, renewable energy sources can help reduce reliance on fossil fuels. Renewable energy sources, such as solar and wind power, can provide clean and sustainable energy. 36thly, energy storage systems can store energy for later use. This can help improve the reliability of the power supply and reduce the cost of energy. 37thly, electric vehicles can help reduce emissions from transportation. Electric vehicles are powered by electricity and do not produce tailpipe emissions. 38thly, building automation systems can control and monitor building systems. Building automation systems can help reduce energy consumption and improve the comfort and safety of building occupants. 39thly, commissioning is the process of verifying that a building's systems are operating as intended. Commissioning can help identify problems and ensure that the building is operating efficiently. 40thly, retro-commissioning is the process of improving the performance of existing buildings. Retro-commissioning can help identify energy-saving opportunities and improve the comfort and safety of building occupants. 41stly, energy audits can help identify energy-saving opportunities. Energy audits can provide a detailed analysis of a building's energy consumption and identify areas where energy can be saved. 42ndly, energy management systems can track and manage energy consumption. Energy management systems can help identify areas where energy is being wasted and track the progress of energy-saving initiatives. 43rdly, demand response programs can help reduce peak demand for electricity. Demand response programs provide incentives for customers to reduce their electricity consumption during peak periods. 44thly, net metering allows customers to receive credit for excess electricity that they generate. Net metering can encourage customers to install renewable energy systems. 45thly, time of use rates charge different rates for electricity at different times of the day. Time of use rates can encourage customers to shift their electricity consumption to off-peak periods. 46thly, critical peak pricing charges high rates for electricity during critical peak periods. Critical peak pricing can help reduce demand during periods of high electricity demand. 47thly, real-time pricing charges rates for electricity based on the current market price. Real-time pricing can provide customers with more accurate information about the cost of electricity. 48thly, community choice aggregation allows local governments to purchase electricity on behalf of their residents and businesses. Community choice aggregation can provide customers with more control over their electricity supply. 49thly, power purchase agreements are contracts between electricity generators and electricity purchasers. Power purchase agreements can provide developers with a guaranteed revenue stream for their projects. 50thly, feed-in tariffs are payments to electricity generators for the electricity that they generate. Feed-in tariffs can encourage the development of renewable energy projects.